The National Topographical System is a mapping system that covers all of Canada. It's produced by the federal government. It contains planimetric data such as contours, roads, rivers, and wetlands. We'll be using the NTS mapping system in this lab. This is the index map for British Columbia. On it, if you look at the top, you'll see numbers such as 115, 105, 95, 85. And on the bottom, you'll see 102, 92, and 82. Those represent block numbers. So you can see that there's about 10 to 15 blocks for all of British Columbia. However, within a block, or a particular block, let's take block 93, it can be broken up into 16 smaller sort of sections or tiles. So if you look at the number 93 on the screen, count down 2 squares, and they're in light gray, and over 2 squares you'll see the letter A. And then as we move west, you'll see A, B, C, D. If we move north, we'll see E, and if we start heading east again, we'll see F, G, and H. And if we went north, we'd see I, and head west again with J, K, L, and then again north, but then heading east, we see M, N, O, P. Those are the 16 block letters for a particular block. So a map such as 93P would represent a 1 to 250,000 map that you could go and purchase either a paper copy or a digital copy of, and when you did that, you would get be able to see the contours, built-up areas, rivers, and wetlands for that particular area. So this is the mapping system that we'll be working with in this particular lab to develop a little program that will tell us what the adjacent block letter is, given a particular block number and a current map we're on, say such as M or N. So what our program has to do is say, given a block and block letter combination such as 82A, what would be the adjacent map sheet? The first thing I want to cover is how block numbers change. So as we head west, the block number goes up by 10. Now, this is for the block number. We have to realize that within a block there's 16 maps. And as we progress within a particular block, we may not jump a block. But once we get to the edge of that block, if we're asked for the adjacent map sheet and we're heading west, then we will have to jump a particular block number. So again, block numbers as we head west go up by 10. Block numbers when we're heading east go down by 10. So again, if we were on the very easterly sheet in block 82 and we were asked to go east again, we would have to jump into the next block to determine what the particular block letter would be. The relationship as we head north is that, again, only if we jump blocks, the number, and say we do jump blocks, then the number will go up by 1. So we'll move from block 82 to 83. Just remember, there are 16 blocks within a map, so we could, if we're on the bottom of, say, 82, we could jump 3 maps without actually leaving block 82. But if we were to jump into the next block, then the number will go up by 1. So, and the relationship heading south is that if we do jump blocks, and again, you're not always going to have the jump blocks, only in special cases, then the block number has to go down by 1. So to review, if we're heading west, it goes up by 10. If we're heading east, it goes down by 10. If we're heading north, it goes up by 1. And if we're heading south, it goes down by 1. And this is only for when you jump from one block to the other. We have to realize that there are 16 blocks within this, say, for example, block 82. So we can move around that particular block without ever jumping out of it. But there will be cases where we have to jump to the next block, either east, north, south, or west, to find out what the adjacent map sheet would be.
So what I'm going to do now is cover how the letters change when we're looking for the adjacent map sheet. So here we have, for example, block 82. It's broken up into its 16 map sheets, A through P. If we look, it follows a zigzag pattern. So it goes A, B, C, D as we head west. Then we immediately jump up north to E and start heading east in the opposite direction, F, G, H. Head north again, I, J, K, L heading west. Jump north again and start heading east. This may seem really complicated in determining what the adjacent letter is, but in the end, when we look at other map sheets around this particular block, we're going to find that the adjacent map letter is fixed. So J is always north of G. B is always south of G. G is always north of B. Let's take M in the upper left-hand corner. So what is north of M? It will always be D. If we take this series of map sheet or letters, we would just simply copy-paste it north, copy-paste it west, copy-paste it east, copy-paste it south. What that means is, in the case of B, what's south? Well, O. And so it doesn't matter when your block number changes, it doesn't affect who is north, south, east, and west of you. That ends up being a fixed relationship. So when something's dynamic, you should have a dynamic solution. So for block number, we do have to be dynamic. We have to ask questions. And the only way to do that is typically with an if statement. Here the relationship is fixed. So a fixed problem should have a fixed solution. And we will be using a two-dimensional array in lab to determine which block letters are north, south, east, and west of a particular center map sheet. Take something like K. N is always north, F is always south, L is always west, and J is always east. That is fixed. And so we can store that in an array. There's no need to throw a lot of code at this, a lot of ifs, or any kind of loops, because it is fixed. It does not change. If you switch block numbers, it doesn't matter. In terms of adjacent letter, that will always be the same. This concludes this video overview.